A potential cause of the tingling is a ground loop. A current path is created between the grounded water heater, tub drain, and electrical panel, causing a voltage potential at the tub's edge. Another potential cause is faulty bonding. Bonding conductors may not be properly installed or have become compromised. Also, electrical leakage might be the reason, where a small amount of current is leaking from the water heater elements through the water and into the tub. Finally, corrosion on the metal components, such as the water heater or drain, can increase resistance and create a voltage potential. Temporarily disconnect the bonding wire between the water heater and tub drain to eliminate the possibility of a ground loop. Inspect all electrical connections to the water heater and electrical panel for loose or damaged wires. If the elements have been replaced and the bonding is secure, the water heater may be faulty. Connect all metal components in the bathroom, including the tub, drain, and water heater, with a single bonding conductor. If the soil conditions make it difficult to achieve a low ground resistance with standard ground rods, consider using chemical ground rods to improve the ground path. The 15 volts tingle is relatively low and may not be a significant safety hazard. However, it's important to address the underlying cause. While 40 ohms is a reasonable ground resistance, it may not be low enough to prevent voltage potential in some cases. Bonding the cast drain line in the tub is important for safety and may help mitigate the voltage potential. Perform the additional troubleshooting steps. If the issue persists, consider consulting with a qualified electrician to further investigate and resolve the problem. Grounding and bonding are critical for electrical safety. The purpose of grounding is to provide a low impedance path for fault current to return to the source, which allows overcurrent protection devices like circuit breakers or fuses to quickly trip and clear the fault. This helps to prevent electrical shock hazards and minimize damage to equipment. Bonding, on the other hand, connects all metallic parts that could become energized during a fault, creating an equipotential plane. This ensures that there are no voltage differences between these parts, reducing the risk of electric shock if someone comes into contact with them. The National Electrical Code, also known as the NEC, provides specific requirements for grounding and bonding to ensure electrical safety. NEC Article 250 covers grounding and bonding requirements for electrical systems. Some key NEC requirements include the use of a grounding electrode system, which typically consists of ground rods, ground rings, or metal underground water pipes to establish a connection to the earth. The NEC also specifies the size and type of grounding and bonding conductors, as well as the methods for connecting them. For example, NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors based on the rating of the overcurrent protective device. Additionally, NEC Section 250.50 outlines requirements for bonding different grounding electrodes together to form a single grounding electrode system. When troubleshooting electrical tingling in a shower with hot water running, several factors should be considered. Firstly, verify the grounding and bonding of the electrical system, ensuring that all metallic parts, including water pipes, are properly bonded together. Check the ground resistance of the grounding electrode system to ensure that it meets the NEC requirements, typically 25 ohms or less. Measure the voltage between the grounded metallic parts and a known good ground, such as a grounding electrode, to identify any potential voltage differences. Inspect the electrical connections to the water heater and other appliances in the bathroom for any loose or corroded connections which can contribute to voltage leakage. Consider the possibility of a ground fault in the water heater or other appliances, which can introduce voltage onto the grounding system. Check the continuity of the grounding conductors to ensure that they are properly connected and providing a low impedance path for fault current. If the tingling persists after performing these checks, it may be necessary to consult with a qualified electrician to further investigate the issue and implement appropriate corrective actions. Grounding and bonding are essential components of electrical safety in residential and commercial buildings. Adhering to NEC requirements and performing regular inspections and maintenance can help prevent electrical shock hazards and ensure the safe operation of electrical systems. When addressing electrical issues in a residential setting, it's crucial to follow a systematic approach to identify and resolve the problem effectively. The initial steps involve gathering information about the issue, including when it occurs, under what conditions, and any specific symptoms observed. Next, a thorough inspection of the electrical system should be conducted, starting with the main electrical panel. Look for any signs of damage, loose connections, or corrosion. Check the voltage and current levels to ensure they are within acceptable ranges. Use a multimeter to test for continuity and resistance in various circuits. If the issue involves a specific appliance or device, inspect it closely for any visible defects or malfunctions. Consult the manufacturer's documentation or technical specifications for troubleshooting guidance. Consider the age of the electrical system and whether it meets current safety standards. Outdated wiring or components may need to be replaced. Once the potential causes have been identified, prioritize the troubleshooting steps based on the likelihood of each cause. Start with the simplest and most common issues, such as loose connections or tripped circuit breakers. Proceed to more complex tests, such as insulation resistance testing or ground fault detection. Document all findings and actions taken during the troubleshooting process. This will help track progress and facilitate communication with other professionals if needed. When working with electricity, always prioritize safety. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Turn off the power to the circuit or device being worked on whenever possible. If unsure about any aspect of the troubleshooting process, seek assistance from a qualified electrician. After completing the troubleshooting steps and implementing any necessary repairs, verify that the issue has been resolved and that the electrical system is functioning safely. Conduct thorough testing to ensure that all circuits and devices are operating as intended. Educate the resident about any safety precautions or maintenance procedures related to the electrical system. Remember, electrical work can be dangerous, so it's essential to approach it with caution and respect. Taking a systematic approach and following safety guidelines can help ensure a successful outcome. When dealing with electrical issues, it's essential to understand the fundamentals of electrical circuits and components. Electrical circuits consist of a power source, conductors, and a load. The power source provides the voltage that drives the current through the circuit. Conductors, such as wires, provide a path for the current to flow. The load is the device or component that consumes the electrical energy, such as a light bulb or motor. The electrical components can be classified as either active or passive. Active components, such as transistors and integrated circuits, can amplify or switch electrical signals. Passive components, such as resistors, capacitors, and inductors, cannot amplify or switch signals but play important roles in circuit operation. Resistors limit the flow of current in a circuit. Capacitors store electrical energy in an electric field. Inductors store electrical energy in a magnetic field. Understanding the characteristics of these components is crucial for analyzing and troubleshooting electrical circuits. Ohm's law describes the relationship between voltage, current, and resistance in a circuit. It states that voltage equals current times resistance, or volts equals amps times ohms. This law is fundamental to understanding how electrical circuits behave. Series and parallel circuits are two basic types of circuit configurations. In a series circuit, components are connected end to end, and the current is the same through all components. In a parallel circuit, components are connected side by side, and the voltage is the same across all components. Understanding the properties of series and parallel circuits is essential for designing and troubleshooting electrical systems. Electrical safety is paramount when working with electrical circuits. Always follow safety precautions, such as wearing appropriate personal protective equipment and turning off the power before working on any circuit. Be aware of the potential hazards of electricity, such as electric shock and arc flash. Use properly insulated tools and equipment to prevent accidental contact with live circuits. Never work on electrical circuits when wet or in damp conditions. Electrical codes and standards, such as the NEC, provide guidelines for safe electrical practices. Familiarize yourself with these codes and standards to ensure that electrical work is performed safely and correctly. The grounding system provides a path for fault current to return to the source, which helps to protect people from electric shock. The bonding system connects all metallic parts of the electrical system together, which helps to equalize voltage and prevent shock hazards. In addition to understanding electrical circuits and components, it's also important to be familiar with common electrical tools and equipment. Multimeters are used to measure voltage, current, and resistance. Clamp meters are used to measure current without having to break the circuit. Wire strippers are used to remove insulation from wires. Pliers are used to grip and manipulate wires. Screwdrivers are used to tighten and loosen screws. When troubleshooting electrical problems, it's often necessary to use these tools and equipment to diagnose the issue and make necessary repairs. A systematic approach to troubleshooting can help to identify the root cause of the problem and prevent future occurrences. Start by gathering information about the problem, such as when it occurs and under what conditions. Then perform a visual inspection of the electrical system to look for any obvious signs of damage or loose connections. Use a multimeter to test for voltage, current, and resistance in the circuit. Consult wiring diagrams and technical manuals to understand the circuit's operation. Use a process of elimination to narrow down the possible causes of the problem. Make sure to document all findings and actions taken during the troubleshooting process. This will help track progress and facilitate communication with other professionals if needed. Electrical issues can be complex and potentially dangerous, so it's always best to consult with a qualified electrician if you're unsure about how to proceed. In addition to the points already discussed, several other considerations are relevant to electrical safety and troubleshooting. Arc fault circuit interrupters, also known as arc fault circuit interrupters, are devices that detect electrical arcs, which are a common cause of electrical fires. Arc fault circuit interrupters are designed to trip the circuit breaker when an arc is detected, thus preventing a fire from starting. The NEC requires arc fault circuit interrupters protection in many areas of the home, particularly in bedrooms. Ground fault circuit interrupters, also known as ground fault circuit interrupters, are devices that detect ground faults, which occur when current leaks from a circuit to ground. Ground fault circuit interrupters are designed to trip the circuit breaker when a ground fault is detected, thus preventing electric shock. The NEC requires ground fault circuit interrupters protection in areas where water is present, such as bathrooms, kitchens, and outdoor outlets. Surge protectors are devices that protect electronic equipment from voltage spikes, which can damage sensitive components. Surge protectors work by diverting excess voltage away from the protected equipment. It's important to choose surge protectors that are rated for the appropriate voltage and current levels. Smoke detectors are devices that detect smoke, which is an early warning sign of a fire. Smoke detectors are required in all homes and should be tested regularly to ensure that they are functioning properly. Carbon monoxide detectors are devices that detect carbon monoxide, which is a colorless, odorless gas that can be deadly. Carbon monoxide detectors are required in homes that have fuel-burning appliances such as furnaces and water heaters. When working with electrical wiring, it's important to use the correct wire size for the application. The wire size is determined by the amount of current that the wire will be carrying. The NEC provides tables that specify the minimum wire size for different current ratings. It's also important to use the correct type of wire connector for the application. Wire connectors are used to join wires together and must be properly installed to ensure a secure and reliable connection. When installing electrical outlets and switches, it's important to follow the manufacturer's instructions and to use the correct wiring methods. Electrical outlets and switches must be properly grounded to prevent electric shock. When working with electrical panels, it's important to be aware of the potential hazards. The electrical panels contain live circuits and should only be accessed by qualified personnel. Always turn off the power to the panel before working on it and use appropriate personal protective equipment. Regular electrical inspections can help to identify potential problems before they become serious. Electrical inspection should be performed by a qualified electrician. During an electrical inspection, the electrician will check the condition of the wiring outlets, switches, and other electrical components. The electrician will also test the operation of ground fault circuit interrupters and arc fault circuit interrupters. By following these safety guidelines and best practices, it's possible to minimize the risks associated with electricity and to ensure the safe operation of electrical systems. Understanding the basic principles of electricity, the types of electrical components, and the relevant codes and standards is essential for anyone working with electricity. In addition to the topics already covered, it's also important to understand the different types of electrical systems. Single-phase electrical systems are commonly used in residential and small commercial buildings. Single-phase systems have 2 or 3 wires: the hot wire, the neutral wire, and sometimes a ground wire. The voltage between the hot wire and the neutral wire is typically 120 volts in the United States. 3-phase electrical systems are used in larger commercial and industrial buildings. 3-phase systems have 3 hot wires, a neutral wire, and sometimes a ground wire. The voltage between the hot wires is typically 208 volts or 480 volts in the United States. Understanding the type of electrical system is important for selecting the correct electrical equipment and for troubleshooting electrical problems. It's also important to understand the different types of electrical loads. Resistive loads, such as light bulbs and heaters, consume electrical energy and convert it into heat or light. Inductive loads, such as motors and transformers, store electrical energy in a magnetic field. Capacitive loads, such as capacitors, store electrical energy in an electric field. Understanding the type of electrical load is important for selecting the correct overcurrent protection devices and for preventing electrical problems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when the current in a circuit exceeds the rated capacity of the wiring or equipment. Short circuits occur when there is a direct connection between 2 or more conductors, resulting in a large surge of current. Circuit breakers and fuses are designed to trip or blow when an overload or short circuit occurs, thus preventing damage to the electrical system and preventing fires. It's important to select the correct size and type of overcurrent protection device for the application. The size of the overcurrent protection device is determined by the ampacity of the wiring and equipment being protected. The type of overcurrent protection device is determined by the type of electrical load being protected. For example, inductive loads require time delay fuses or circuit breakers to prevent nuisance tripping. In addition to overcurrent protection, it's also important to provide overvoltage protection for sensitive electronic equipment. Overvoltage protection devices, such as surge suppressors, are designed to protect equipment from voltage spikes caused by lightning, power surges, or other electrical disturbances. Surge suppressors work by diverting excess voltage away from the protected equipment. It's important to choose surge suppressors that are rated for the appropriate voltage and current levels and that are installed properly. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to protect people from electric shock. Grounding also helps to reduce electrical noise and interference. The grounding system consists of a grounding electrode, a grounding conductor, and equipment grounding conductors. The grounding electrode is a metal rod or plate that is buried in the earth. The grounding conductor connects the grounding electrode to the electrical panel. The equipment grounding conductors connect the metallic parts of electrical equipment to the grounding system. Bonding is also essential for electrical safety. Bonding connects all metallic parts of the electrical system together, which helps to equalize voltage and prevent shock hazards. Bonding is typically accomplished by using bonding jumpers or bonding screws. It's important to ensure that all metallic parts of the electrical system are properly bonded together, including metal water pipes, gas pipes, and metal conduits. Regular maintenance of electrical systems is important for ensuring their safe and reliable operation. Electrical systems should be inspected regularly for any signs of damage or deterioration. Loose connections should be tightened, and damaged wiring should be replaced. Ground fault circuit interrupters and R fault circuit interrupters should be tested regularly to ensure that they are functioning properly. By following these guidelines and best practices, it's possible to minimize the risks associated with electricity and to ensure the safe and reliable operation of electrical systems.